Hello, everyone. So in this video, I would like to show you how to evaluate functions from a given graph and how to find domain and range of a function just by looking at the graph. So before we start evaluating function values, let's talk about briefly what is a domain and range. So as we all know, hopefully at this point, you know that the domain is the set of x value. So if you take a look at this graph we have here, domain is this portion right here. So it's where the graph exists from left to right. And we see that the graph here, it exists from here and all the way to here. So we can say that domain will be from that point all the way to that point, whatever those x values are. Here we don't have an x value, it's just an illustration. And range is the set of y value corresponding to the x values. So range will be the y values then. So the lowest y value it exists is right here. And then the graph exists all the way up to here. That would be the range for this given graph. So knowing that domain is the set of x value and range is the corresponding y values, we can now let's take a look at some examples. So for this problem, I would like to look at a few things. So first we're going to find, now let's suppose this is the graph of f. So first we want to find what is the domain of f. And then we're going to talk about what is the range of f. So domain, again, is the set of x value where the graph exists. So the graph exists here. So we can say that's -3. And the graph exists in all of this up to this point, and then it stopped existing. So we can say the domain, again, because these endpoints are closed, so we can say that the domain is -3 all the way to 3, closed, because both endpoints happen to be closed. Now, what about the range? Well, range is the corresponding y values. So for range, if we look at the y values, from bottom to top, we see that the lowest y value is right here. That's 1. Again, it's inclusive, so that's -1. And then the graph exists everywhere all the way up to here, because that's the height. That's the highest value the function reaches. So we can say that it goes all the way up to 4. So that will be our range for this function. So I hope this makes sense. Now let's talk about evaluating functions. So what if we want to evaluate, say, f of, for example, 2? If we want to evaluate f of 2, this is the graph of f. So we look at the graph at x equals 2, and we want to read off the function value at 2. So 2 is right here. Let's suppose that's 2. And the function value at that point, it's going to be this point right here. So we can say that's 3. So f of 2 is going to be 3. Similarly, you can find more points on these functions. Let's say, what about we're looking for f of 0? So that means we're looking at x equals 0. We want to know what is the y value. So 0 is right here, and that is the y value. And it looks like it's -1. So f of 0 would be -1. So pretty much that's how you would read function values from a given graph. All right, now let's take a look at another example. All right, so here's another example. Again, first we want to talk about the domain of this function. So let's say we want to find domain of f. And then we're going to talk about the range of f. And then we'll evaluate some function values. So domain, we want to see from left to right where the function exists. So it looks like the graph starts to exist from here. That's -4, including -4. And then it exists all the way up to here. That'd be +4. So that is the domain of this function. What about the range? Well, that's from lowest to highest, the y values. So the lowest, we can see the graph exists is right here. So that would be, since it is scaled by 1, that would be -2, again, including because there is no open circle, and then all the way up to this point. Now you might say this is open, but then because of this point, it's closed, that endpoint is actually closed. So we can say up to 3, again, closed. So that would be our domain and range for this particular function. Now the next portion, we want to figure out what is, let's call, what is f of, let's do f of -2, and then we'll find out what is f of 2 is. Let's find those function values. So f of -2, we're looking at when x is equal to 2, what is the function value? What is the y value? So x equals 2, well, that's right, -2, I'm sorry, that's right here. So we look at the height, it stops right here. So this is probably 2. So -2, the function value of -2 is 2. All right, now what about f of 2? Well, it looks like 2 is right here. And if I read off, well, you might say there is 2 height, but no, the top one, this is open. So because it's open, the function is not defined at that point. So the only point it is defined at is this one right here. So f of 2 would be 1. So there you have, we evaluated 2 function values for this graph. Okay, let's take a look at our last example. All right, so we will be answering these set of components for this graph. So first we're going to find the domain of this graph. So let's see where the graph exists. So the graph is defined from this point all the way to this point right here. So that would be, this is about -2. So we can say the domain is -2. Again, the function is defined here. So that's -2 all the way to 2. Again, including these endpoints because they happen to be closed. Now, what about the range? So the range is the set of y values. So for y values, it looks like the lowest the function goes is right here. That's -2. And the highest, the graph exists in all of this all the way up to here. So that would also be 2. So that's the domain and range for this graph. Okay, so now let's find these function values. So for the first one, we're looking for f of -1. Well, -1 is here. So of course, there's 2 places you might wonder that this function is defined. But of course, one of them is open circle. So because this is an open circle, the function is not defined at that point. So the function is defined at this point. So that would be -1 is equal to, will give us the function value to be -1. That's why it is evaluated. Now f of 0, so 0 is right here. And it looks like the function is defined at that point. I'm just going to estimate, I will just call that to be f of 0 is also 0. It looks like it goes through 0, 0. And the last one, f of 1. So for f of 1, we are looking at this point right here. So when x is equal to 1, again, there is an open circle, there is a closed circle. Open circle is where the function is not defined. Closed circle is the one we're going to read. So f of 1 has to be this point. So that will be at 2. So f of 1, it's going to be 2. All right, so I hope these examples help you to understand this topic. All right, I'll see you next time.